Okay, so here's essentially the breakdown of our unit, okay? So what makes this unit test tricky, so the unit test is tomorrow, what makes it tricky is it's not in the order that we covered the unit. That would make it way too easy because you would literally then know that all the permutation questions came first, all the combination questions came at the end, right? It would make it way too simple for you. And that's the way the diploma, it jumbles it all up. So we're required to be able to look at something and know if we're talking about a permutation or combination. So with every single question that you see, you're going to ask yourself, does the order matter? How you can tell if the order matters is if you're doing an arrangement versus a selection. Okay, arrangement versus selection. Let's do the combination way first. If it's a selection, it's just NCR. Remember, it can also be written like that. Okay, N, this is the total number of objects. Whereas the R is the number that you're selecting. Now, N has to be bigger than R, right? You can't select more than what you have. Like if I need a group of 12 and I've only got 8 of you in front of me, I'm out of luck. Okay, right, yes. Okay, so it has to be like 12 choose 8, not 8 choose 12. And you'll know that you're doing it wrong is if you punch in 8 choose 12 on your calculator, you're going to get an error message. Okay, it has to be N is bigger than R. Now, the ones we did yesterday are the at most and at least. If you do see those questions, what you're going to do is you're going to do the NCR, and then you're going to add it to the next NCR, you're going to add it to the next NCR. So you're going to go through and add up all your different cases. So if it says at most 2 females, that would mean 2 females, 1 female, no females. Okay? So you add up all your cases. So the NCR questions are pretty self-explanatory. Like there's not a lot to them. Okay, it's just NCR. You're looking for the word select. You're looking for the fact that the order does not matter. Okay. For permutations, this is the 98% of your questions, you're going to do them by the blanks method. Okay, so you're going to figure out how many blanks to draw, do the restrictions on the blanks first. So in terms of just some basics here, your digits run from 0 to 9, which means you have 10 choices for digits, not 9. Okay. Letters go from A to Z, meaning you have 26 choices for letters. 5 are vowels, 5 are consonants. Okay. Do pay attention to if the question allows you to have repeats or not. So if it's a Scrabble tiles question, like how many ways can you arrange the letters of the word children? Okay. You're assuming each letter is on its own Scrabble tile, so the assumption is no repeats because you've only got one C, one H, one I. If you're looking for the number of possible phone numbers, so Myers is 223-2292. Repeats are allowed. So it would go 10, 10, 10, 10, 10, 10, 10 for number of choices you'd have. Okay. If a question says how many odd numbers are possible, that means it ends in an odd number, not starts with an odd number. Okay. So all those word questions that we did. Now, you can do these questions using NPR, but you can only use NPR if the blanks count down by ones. So in other words, no restrictions. So you have, let's say this semester you have 7 textbooks, but you're only strong enough to carry 3 at a time. So it would be 7P3. Okay, because you would arrange them on it, or sorry, not carry them, you'd arrange them on a shelf. So 7P3, or 7 times 6 times 5. Okay. With this being, because I'm kind of switching you here too, because your test is multiple choice, numeric response, short answer. Okay. On the multiple choice, if you figure it out using blanks, but all the multiple choices are NPRs, plug yours into the calculator, plug theirs into the calculator, match them up. Okay. Okay, and then we've got the special restrictions. So repeats, you can also think of it as identical objects. Whoops. So if you have identical objects, the numerator is the total number. The bottom is each identical object. Remember, when you plug this into your calculator, you've got to have brackets around that denominator. Okay. Now, it's not always letters of a word. So for example, Mississippi is an obvious word with lots of I's, lots of S's, lots of P's. Toronto, Canada, repeated letters. Okay. The tricky ones, like the one on the quiz, was freezies. So you had a box of 12 freezies. You had 4 cherry, 4 lime, and 4 apple. Okay. So it would be 12 factorial over 4 factorial, 4 factorial, 4 factorial. Because you have repeated limes, repeated cherries, and repeated whatever other flavor I said. Okay. So it's not always about letters repeating. That's why I say don't think of it as repeats, think of it as identical objects. So if in that question you have, so for example, if we have a row of houses, let's say we have 8 houses, and they're all the identical, let me make it even easier, car lot. You go over to Chev. They've got the exact same 4 cars, same color, same model, same everything. So they've got 4 white cars, 4 black cars, and 4 gray cars. How many different ways could you arrange them? 12 factorial over 4 factorial, 4 factorial, 4 factorial. Okay, those are identical objects. Okay. And then unfortunately, the purple there, together, not together. You simply have to have that formula memorized. So with the together, so what you do is you duct tape whatever you're sticking together. So let's say if you duct tape 3 things together, it'd be 3 factorial. Now when you duct tape those 3 things together, they're going to now count as just one thing. So you are going to have a new total number of things that you are arranging. So for example, if you started out with, let's say 7 people, but we're going to stick 3 people together. So 1, 2, 3, 4, 5, 6, 7. So I've still got 7 sticks, but 3 people are going to stick together. So I've got 3 things in the box, and then you times it by 5 factorial. 1, 2, 3, 4, 5. That's your new total. Now, the only time you wouldn't times it by 3 factorial is if it told you that there, let's say those people in the box, let's say they had to stand in order from shortest to tallest. Well, how many ways can you stand from shortest to tallest? One way. So it would be 1 factorial times 5 factorial. Okay. And then the not together questions, these are just the opposite. So not together is you do no restrictions. So it would be 7 factorial for 7 people minus they are together. So you would just punch that into your calculator. So most of this is, there's nothing really, you just have to read the question and hope that you're doing it right. There is that small memorization piece for the identical objects formula and the together formula. Those are the 2 formulas you have to have memorized. But here's the thing, it's not even a matter of memorizing the formula, it's knowing when to use it. That's the hardest part of this. Okay? So what we're going to do is we're just going to deep dive in and just do just a bunch of questions together. Okay, and let's see how many we want to do. I'll kind of get a feel for how good you guys are doing with this. I'm just going to go straight to the assignment on page 109. I want you to X out question 4C, 8, 9, and 14. And also number 10 we're going to change. So put a star beside number 10. I'm going to change the question to something more 30-2 appropriate. Okay? Okay, so let's just do a deep dive in. And we're just going to go into the assignment. And we're just going to start on number 1, see where we go. Okay? So we're going to read the question together. I'm going to pause for a minute. So I'm going to hit pause on the video, give you a minute to think about it, and then go from there. Okay? So a basketball squad of 11 players is to be chosen from 17 available players. In how many ways can this be done if Jeff and Brent must be selected and Jeff and Brent cannot both be selected? Okay. So I'll give you a minute to think about that. Okay, sorry. So before we do that question, let's just look at this. So there's a concept on the diploma. It's probably going to be a numeric response question. They would have each of these things numbered. So they were like number 1, number 2, 3, 4, 5, 6, 7, 8. A numeric response question would be is, which of these following scenarios are permutations? Place the numbers on the formula on the answer sheet. Or they'll say which of the following are combinations. And again, it would be a maximum of 4 answers, right? So recognizing when you have a permutation versus when you have a combination is actually almost a guaranteed diploma exam question. It's in 30-1 as well. Okay. So let's just go through and look at this. Inviting friends to a party. Would that be a permutation or a selection, a combination? It's a selection, right? It doesn't matter what order you invite them in, you just invite them, right? You're just sending out invites. So this would be a combination. Dealing a hand of cards for a game. So how many different hands could you be dealt with? Combination or permutation? Combination. Because what's the first thing you do once you get those cards? So you put them in the order that you want anyway, right? So the order doesn't matter. Ordering racers as they finish a race. So how many? So they got 8 cars in a race. First, second, third. Permutation or combination? Permutation. Right? Because you're ordering. Because like if the blue car gets first, that's different than if the blue car gets third. Right? So the order of them finishing matters. Putting books in a pile with my favorites being on top. Does the order matter? Yes. Permutation. Because then books on. Right. Because you're just selecting. Right? Yeah. But and it's an order now. Yeah. Making an ingredients list for a tossed salad. Combination. Order doesn't matter. You see how it helps thinking of order, right? Does the order matter, yes or no? And if once you have that, then you're into like, oh my gosh, permutation land or woohoo, combination land, right? Like it kind of separates you up. Creating a password. Permutation every day. It's just like your PIN. It's not enough to remember the 4 numbers. You got to remember in the correct order. Okay. Arranging Scrabble tiles to form words. Permutation. Because again, the key word here is arrange. The numbers on a combination lock. This is a permutation. Look, it's called a combination lock because it's called your locker combo, but it's still a permutation. It's not enough to remember the 3 numbers in August. You have to remember them like 27, 16, 32. It's not enough to go 16, 32, 27. You're not going to get it open. You have to go at the right numbers in the right order. This one is mean because we put the word combination in the explanation, but it's actually a permutation. Okay? So we have here, so for example, if the question said, which of these are combinations? The answer would be 1, 2, 5. That's what you would color in on the numeric response sheet. Okay? Does that make sense? Okay, so deep dive in. Let's try number 1. So you've got 7 players. You're creating a squad of 11. So what we'll do is we'll just do the setups. We won't worry about doing all the button pushing on the calculator. Okay? So is this a permutation or a combination? Combination. Okay? Because you're not arranging them in a line for a photo. You're just selecting 11 players from 17. Okay? So you have to select Jeff and Brent. So you've got Jeff and Brent. So those are two players, and you have to select both of them, right? Do the restriction first. So how many players do you now have left to pick from? You've selected Jeff and Brent. You've got 15 left. How many positions left to fill? 9. So you've got 15 players left to pick from. You want 9 of them. So this is the rest of the players. So this squad consists of Jeff, Brent, and the rest. So let's multiply. Okay. We won't worry about part B. Part B is beyond Math 30-2. Okay. Well, 2 choose 2 just equals 1. Like this just equals 1. So you're just going to go 1 times 15, choose 9. Yeah, which will give you the right answer. Yeah, yeah, yep. Because think about it, how many ways, so if I say, so if you two were the only two that showed up for class today, how many ways can I select you two and just you two? One way, you and you, come with me, right? Okay, let's look at number 2. 15 rugby players line up for a team picture with 7 players in the front row, 8 players in the back row. Express your answer in factorial notation, don't worry about that. Determine the number of arrangements of the 15 players without restrictions, and if the captain is in the middle of the front row. So I'll give you a minute. Okay, it actually doesn't matter that there's 8 in the back and 7 in the front. That's actually irrelevant to the question. It's essentially saying you have 15 players and you're going to arrange all of them, right? So how could you write this? You've got 15 players, you're arranging all 15 of them. If you want to do it with the blanks, how many blanks, how many choices for the players do you have for the very first position? Back row, far left. 15. Then all the way down to 1 choice for that last guy. Okay. Now, the part B says the captain is in the middle of the front row. So middle of the front row, here's the captain. How many captains do you have? 1. So you place the captain. How many players do you now have left to put in? How many choices for this blank right here? 14. Then so essentially you've got 1 times 14 factorial or 1 times 14, and you're going to arrange all 14 of them. The blanks help because you should always end up at 1, right? Because if you do the blanks and you count down properly, you should end up at the 1, right? Whereas if you haven't counted properly, you know you're going to struggle with that. Okay, but again, the restriction here is captain has to be in the middle, so we put the captain first. Now, on the diploma, they would probably say, Joe, the only captain, goes in the front middle row. Just to remind, just so that you understand that there's only 1 captain. Okay, so on the diploma, I'll tell you this right now. These questions, even though for some of you they're going to drive you a little nutty, they're extremely well worded. There should be no gray area in your brain going, well, what if there's more than 1 captain? Nope. And if they're not sure if they have explained it properly, they'll put a couple examples of what they're talking about. They'll be like, this and this are examples of what we're talking about. This is not an example of what we're talking about. So you can see like, oh, so the number can't start with a 0. Or, oh, look, the repeats are okay. So they'll often do examples to show you that what's acceptable. Because again, we can't assume that everybody in Alberta reads at the same level. A lot of students have ESL as have English as a second language, sometimes a third or fourth language. Okay. Okay, let's look at number 3. Okay. So it says determine the number of arrangements. Automatically you see the word arrangement, you're thinking permutation. Okay? Of the letters of the word tattoo. Okay. The word is tattoo. What do you notice about tattoo? Identical objects. Okay? So what that means is that it doesn't actually matter what these questions are asking. Every single one of them, how many parts are there? 4, A, B, C, D. Every single one of them will have the exact same denominator. So when I see identical objects, I actually stop reading the question and I do the denominator. Because I don't, the numerator comes from the question, the denominator comes from the identical objects. So how many identical objects do I have? 3 T's, 2 O's, right? So 3 T's, 2 O's. So I don't even care right now what the numerator is. I know that that's what the denominator is. Always do that first. If you recognize identical objects, jump to the denominator. Now go in. Okay, so again, imagining Scrabble tiles here, okay, because it's a word that we're rearranging. So we have 6 Scrabble tiles, okay. The arrangement has to begin with a T. So it has to begin with a T. So how many choices do you have for the first one? 3. Okay, so let's say I selected this tile right here, that T. So that tile is out of commission. How many tiles do I now have left to pick from? 5. So 5, 4, 3, 2, 1. So it's 3 times 5 factorial over 3 factorial, 2 factorial. Now just as a reminder, bracket, bracket, right? It would be tragic if you put all this work in, had everything set up perfectly, and then you plugged it in wrong, so you colored in the wrong numeric response. That would be tragic because you clearly know what you're doing. And by the way, that is my issue with standardized tests is it's testing to see if you can color in dots. It's not testing if you actually know the material or not. Okay. Okay, part B. So I'm going to go quiet here, give you a couple seconds to think about this. Begin with 2 T's. C is begin with 3 T's. And D have all the T's together. Okay, so what if it has to start with 2 T's? Okay, we already know there's 3 choices for the first T. How many choices for the next T? 2. So let's say I've now picked those 2. How many Scrabble tiles do you now have left? So 4, 3, 2, 1. So you would just punch that in, happy, happy, happy. Okay. Okay, 3 T's. How many choices for the first T? Then how many choices for the next T? How many choices for the next T? So we've used up all our T's. So how many letters do I now have left? 3, 2, 1. Now, just as a thing on this one, I'm just going to show you here how they might write the answer and how you calculate it are not necessarily the same thing. Here's what I mean. Do you understand that 3, 2, 1 is 3 factorial? Do you understand that 3, 2, 1 is 3 factorial? Our denominators never change. Do you understand that you can cross those 2 out? So the ABCD might be shown just like this instead of as a number on your page. This is where you do not freak out. What you're going to do on these questions is you're going to calculate them exactly the way we have practiced. You're going to punch this in exactly the way we've practiced. And then you're going to go through the ABCD and punch theirs in how they've got written. One of them will match. The number one thing kids do wrong in this unit, my 30-1s do it even more than you guys, is you try to make your thinking match how they've got the answer written. And it's never going to work. Here's case in point. You know you've got 3 T's and 2 O's. If the ABCDs are written like that, you're going to be like, whoa, hold on. What happened to the 3 T's? I thought there was 3 T's and 2 O's. Where's all my identical? You're going to freak yourself out. And you're going to second guess everything that you've learned. And you're just going to start madly circling C because you have no idea what you're doing. Stop. What I want you to do on these questions is when you read it, put your hand over the A, B, C, D. Don't even think about looking at it. Okay, so put your calculator case over it, put your hand, whatever. And then in the space provided, do the work. Then reveal and go, oh, there it is. Okay, these are not questions where you work backwards from the answer. Absolutely 150% do not do that. Treat each question as a short answer question and then reveal once you've had a kick at it. If you have no idea how to do the question, honestly and unfortunately, on this section of the course, if you have no idea how to do a question, there's very little you can do to help yourself. You're just going to have to be like, you know what, I haven't had D in a while, circle it, move on. Because you can't work backwards from the answer, right? The only thing that you could possibly do is if you, let's say, two of the answers are written with NPRs and two of the answers are written with NCRs. If you recognize that this is a C question instead of a P, you could eliminate the P choices and then pick one of the best two of the C's. But that's about all you can do with this. It's a polarizing unit, unfortunately. Okay, part D. This one I think is beyond 30-2 scope, but let's give it a go. The idea of combining, what it is this is combining an identical objects question with a together question. And I think that that is beyond the scope of 30-2. It's fair game in 30-1, but not necessarily in 30-2. So our three T's have to be together. So as soon as you see the word together, you're going to take out your duct tape and you're going to stick them together. So now those are our tiles. So what is my new total? New total is 4 times by the number of items in the box. And it doesn't matter that the number of items in the box are identical. It doesn't matter. How come? Because look, they cancel each other out anyway. The 3 T's cancel off with the 3 T's. So it ends up working out regardless. Okay? But we're really trying to get you to focus on the keywords here, like arranging, selecting, together, identical objects. Okay? Slow down. Slow down. Okay. 4A. 10 students have been elected to serve on a student council. In how many ways can 4 of these students be chosen to represent the school as ambassadors at the provincial election education conference? In how many ways can a president, vice president, secretary, and treasurer be chosen from the 10 students? And then part C, we're not going to do. Okay, so 10 students have been elected on a student's council. How many ways can 4 of these students be chosen to represent ambassadors as ambassadors? Well, permutation or combination? So it is how many choose how many? Yep, that's it. Okay, in how many ways can a president, vice president, secretary, and treasurer be chosen from the students? Okay, from the 10 students. Okay, so let's say it's you 4. Okay, your president, your V, your secretary, your treasurer. Okay, would that be different than going president, vice, secretary, treasurer? Is it different? So does the order matter? Yes. So this one is a 10P4 because the order matters. Or if you don't like that, you've got president, vice, secretary, treasurer. How many choices do you have for president? How many choices do you have for vice? For secretary? For treasurer? I know, it's like the combination lock. Yeah, it's essentially these ones if you're putting a delegation to the selection. So if you're delegating those 4 positions. Another one would be, okay, I need 3 of you to come with me. That is an 8 choose 3. Okay? But if I say, okay, first person that I pick gets a Mars bar. Second person that I pick gets a double, double. Third person that I pick gets a donut. Does the order matter now? So that would be an 8p3. So when I put delegation to the selection, then it becomes a permutation and not an arrangement anymore. Nitpicky, right? This is not the unit where you skim. This is not the unit where you experiment with an energy drink before the test and like you can't focus, okay? Nuh-uh. No, don't go there. I'm feeling pretty good right now, but I've only had a couple sips. Yeah, I did. Yeah. I've only had a couple sips and I'm not feeling too bad, but yesterday I actually felt like while I was teaching, I was like, I'm gonna be sick. I'm gonna puke. I'm gonna die. I actually felt my eyes going like different directions. It was just horrible. Putting on a front. Okay, number 5. A bakery is 4 blocks south and 5 blocks northwest of a supermarket. Okay, so if you're the type of person who believes that whenever you're driving downhill, you're heading south, whenever you're heading uphill, you're heading north, me included, that's going to be terrifying. They're always going to give you a picture. Okay, they're always going to give you a picture because most of us don't know our north, south, east, west because we have Google Maps, right? We don't have to know. So it says the bakery driver, bored with traveling the same route, decides to use a different route for each delivery. Look at him go. Assuming that he always travels closer to the supermarket, how many deliveries are possible? So this is counting corners. Okay, so put your ones on there. So I'm going to do it quietly up here. Now, does it matter technically what corner you go from and what corner you go to? No, you can start in any corner and go to the opposite corner. So start with your ones along the edge and then build your way across. Adding your corners as you go. Shocking. We're in math class. Now, if you should get out 126. Now, if you don't want to do counting corners, the other way, because it is a basic rectangle, the other way you could do it is say, look, 1, 2, 3, 4, 5. I've got 5 movements to the right. I did 20 plus 15 is 35. And then 4 units up. So you've got 5 blocks right and 4 blocks up. So that is a total of 9 blocks with identical objects. So if you don't want to do counting corners, you can do it that way. Okay. I personally prefer counting corners, but I'm also at the point where I rarely write 3 plus 3 is 9, right? So I do those mistakes, and unfortunately on counting corners, those mistakes happen. Whereas the permutation way works splendiferously, but you can only use the identical objects way if you have perfect rectangles. Okay. Okay. I just want to read through number 6. We're not going to do it. We're just going to read through it. So it says a town has 6 streets running from north to south and 4 avenues running from west to east. A man wishes to drive from the extreme southwest to the extreme northeast. Tania used the expression 10 factorial, 6 factorial, 4 factorial. This is wrong. Why? Okay. You've got 6 running this way and 4 running this way. 1, 2, 3, 4. Okay? She is here. You want to get to here. Don't do counting corners. Think of it as a permutations question. You want to go 5 right and 3 down. So the formula is 8 factorial. 5, 3, not 10, 6, 4. Yes, there's 6 avenues and 4 streets, but that results in 6 minus 1 is 5, 4 minus 1 is 3. So it results in 1 less, because remember, you're going from corner to corner. Corner to corner requires 2 streets, but that's still only 1 movement. So again, the diploma, it will give you the picture. So they might give you that written paragraph, but then they will draw this underneath. Okay. Okay. Let's look at let's just jump around here a little bit. Let's go to number 11. Let's try some multiple choice questions. Okay. So a student enrolled in a general studies program at a particular university a student enrolled in a general studies program at a particular university must take 4 courses in the first semester. So they have to take 4 courses. The student must take English, either math or psych, and either 2 courses from group A or 2 courses from group B. The number of 4 course programs available to the student is. Okay, put your hand over the ABCD. Don't even try to reason it the way they've got it written. Okay? Step 1. Does the order matter? Are you arranging courses or are you just selecting your courses? You're selecting your courses. So this is a C question. Okay? It's an NCR. It's not saying how many timetables you can make. What would timetables be? A permutation, right? Because having English first block is different than having English last block, right? That's not what we're doing here. Okay, let's start with English. You have to have English. So you've got 1 English and you have to take it. Right? You have to take either math or psychology. So you've got 2 courses. You have to select 1. Now, before we get any further, your schedule has to include English and math or psych. And now, here's the tricky bit. You either have to pick 2 classes from group A or 2 classes from group B. So if you pick 2 from group A, okay, so one schedule is English, math or psych, and 2 from group A. How many choices do we have in group A? How many? 5? You want 2 of them. So that's first option. The second option is the same thing. English, math or psych, 2 from group B. How many courses in group B are there? 4. You want 2 of them. So your schedule will either be this or that. So then you would take this answer and add it to that answer. Reveal. Now, the way they have it written, okay, what is 1 choose 1? It's just 1, right? So they don't even have that listed there. So what you could do, what I would do is I would just punch this into my calculator. I would go 2 choose 1 times 5 choose 2 plus 2 choose 1 times 4 choose 2. And then I punch in the A, B's. Now clearly, do you even have to plug in C or D? No. So you just plug in A, plug in B, and then match it up. My point is that the way they've written it and the way you think about it are not always the same thing. Okay? Okay, let's look at number 12. Okay, So it says, and again, number 12, this is an example of overthinking something. Customer service reps at a men's designer store must wear company attire. They have a choice of 3 shirts, 4 ties, 2 pants. The number of different outfits that a customer service rep could create is what? Now, what does choice, let's go through this backwards actually. If you picked A, you're telling me it's a selection, okay? What 9C3 means, so where does the 9 come from? 3 plus 4 plus 2, right? 3 shirts, 4 ties, and 2 pants. What 9 choose 3 means is you could select any 3 things from those 9 to wear. So you would only put on, you could possibly only wear 3 ties. That's it to work that day. Is that what you mean? Yeah, please wear pants. 9B, or sorry, 12B means, again, you could wear 3 ties, but you select them in a specific order. That's not what you mean either. Choice C, see how it's got a denominator? Choice C means what? Identical objects. Are the shirts, the ties, and the pants identical? Are they identical? Read the question. It says 3 different shirts, so it's not choice C either. This question is just, it's what we did on day 1. You've got to wear shoes, pants, oh no, shirt, pant, and tie. How many shirts do you have to pick from? How many pants? And how many ties? 2. 3 times 4 times 2. That's it. Now, if you want to think of this as a selecting, right? Because like, does it matter if I select my pants first, then I select my shirt, then I select my tie? Like, does it matter what order I select them in? No, because I can end up with the same outfit. So if you want to think of it as a select question, you would do it like this. This and this have the same answer. What you're not allowed to do is group them together as a total, because you could inadvertently pick 3 ties to wear, and that's all you wear that day. That's the problem with choice A and B. So if you have no idea how to do a question, in terms of working backwards from the answer, can you work back from the answer? No. But can you think about the answers and go, yeah, there's no way, because if I group them all together, I could just pick 3 pairs of pants and now that's all I've got to wear for the whole day. That's not right. And then you cross it off. Okay. Did I say to take off question number 13? No. So let's look at 13. So it says, on the floor of her study, a student has 5 different English books, 2 different science books, and 2 different math books. The number of ways in which 3 of the books can be arranged on a shelf. So if you hide the answers, how many books do you have? How many books do you have in total? 9. You're arranging how many on a shelf? 3. So which is the answer? A, B, C, or D? B. 9 arrange 3. 9P3. Or in other words, you've got 3. How many choices for the first book? 9. Then 8. Then 7. Why am I not dividing by repeats? Because they aren't identical objects. It tells you in the question that they are different. Okay? So if you go 9 times 8 times 7, you'll get out the exact same thing as going 9P3. Okay? So again, if none of those answers make sense to you, hide them. Do it how you would reasonably think about this. Okay, don't do number 14. You've X'd that one off. Okay, let's look at 15. I'm going to go quiet. The number, you've only a couple more left, I promise. Okay. The number of arrangements of the letters of the word student in which the 2 T's are not adjacent. Okay, adjacent is another word for together. So this is a not together question. So do you know your formula for not together? Okay, so if you're struggling with the formula, it's no restrictions minus the T's are together, right? You do the opposite, right? You go no restrictions minus the opposite. So the opposite would be that they are together, okay? So what would no restrictions be? Now this question is tricky, okay? This is definitely like pushing a 30-1 kind of boundary here. How many Scrabble tiles do you have? Pardon me? 7. Now, has anyone caught the fact that you have identical objects? There's 2 T's. So my no restrictions is 7 factorial over 2 factorial. Minus. Okay, let's duct tape those 2 T's together. Because this is the opposite now. Oops. Okay, so you've duct taped the 2 T's because it's no restrictions minus the opposite. The opposite would be the 2 T's are together. So what is your new total? So we go 6 factorial times 2 factorial, but you still have to divide by the repeats. Remember, the repeats doesn't change. No matter what's going on in the question, you always have the repeats on the bottom. So you would plug this monstrosity into your calculator. Okay, and you should get out the right answer. Okay, we're going to skip over 16. We'll come back to it. Let's do number 17. A coach must choose the 5 starters for a basketball team from 6 males and 5 females. If there must be at least 2 of each gender in the starting lineup, then the number of different groups of players that can be chosen is. Okay. Okay, I know it sounds stupid for me to say this, but think about this. How many players are you picking? 5. Okay? You must have at least 2 from each gender. Okay, so that means, so what does that mean? What's one option? You could either have 3 guys and 2 girls, right? That would be at least 2 from each gender. Or what's the other option? Right, 3 girls and 2 boys. Is there any other options? Could I go with a 4 and a 1? No, because now I haven't picked 2 from each. So once you see that, this is now easy. But you have to take a step back and go, hold on. What does it mean at least 2 from each gender? I literally just took that entire question and made it into that. Whenever you can get the language to go away and the numbers to come in, you want to take the time to do that. Okay? So how many guys do we have to pick from? And how many girls? Okay, so I'm going to go with the guys. So 6 choose 3. And here's the guys is 6 choose 2. For the girls, we have 5 to pick from. So 5 choose 2 and 5 choose 3. So in that starting lineup, do you understand that 1 times 2 is the same as 2 times 1? Right? So does it matter what order I put these in? No. So my lineup needs guys and girls. So I go guys and girls or guys and girls. Now, is that horrible to plug into your calculator? Yep, it is. Suck it up, buttercup. You got 6 hours. Okay? Notice its numeric response. So you either get it or you don't. That's what I mean. This unit is polarizing. You either can do it, and you have to be able to do the whole thing. It's not a matter of going, well, I understand this case, but I don't really understand the other cases, so I'll get half a mark. On my test, you will. On their test, you won't. Okay? The average on the diploma is typically about 15% lower than what your class mark is going in. Just because you get no credit for your work, you simply get it marked right or wrong. The long answer questions will actually be your saving grace because you actually get a whole bunch of marks for all your effort. Okay, let's go back to number 16 and then we're done for the day. Okay, so it says, okay, don't freak out with it. This one is weird and we haven't done anything like this either. This is kind of like the handshake question from yesterday or from 2 days ago. Remember when when you shake hands with somebody, you're creating a group of 2? So it's a something C2. This kind of same idea. 35 different quadrilaterals. Okay, what is a quadrilateral? Any four-sided shape, okay, can be formed by connecting points on the circumference of a circle. Okay, circle, points. I don't know how many I have, just points. So I could connect this one to this one to this one to this one. There's a quadrilateral. Yes? I could connect this one to this one to this one to this one to this one. Is that a quadrilateral? Did the order that I connected the dots matter? No. Here's another one. I could connect this one to this one to this one to this one to this one. Or I could connect this one to this one to this one to this one to that one. The order that I connect the dots doesn't matter. But I know I need to connect 4 dots. So what this question is saying is you have to select 4 things. How many dots do you have to pick from if there are 35 different ways for that to occur? So all you're going to do is guess and check on your calculator. Now, hold on. What is the absolute smallest this could be? Well, hang on. How many ways can you select 4 things from 4? 1 way. So it's not going to be 4, choose 4. So I would start at 5, 6, 7, 10, 20, until you get out 35. And you just guess and check using the NCR button on your calculator. If you look to the bottom of the page, you can see that it's 7. Yeah. So, so these questions are not hard. They're not hard, but it's recognizing that first off, it's a combination, and second off, you're creating groups of size 4. They're weird, right? They're weird. It wouldn't probably occur to you to ever do it this way, right? Okay, but here's the thing. The only other option you would have to do this is to draw a circle with 5 dots on it and connect 4 of them at a time and see how many shapes you get. And if that doesn't give you 35 shapes, now create a picture with 6 dots on it. And then it would take you forever. Don't do that. Okay? Okay.